gelatinous precipitates. Like the reason why you can see this stuff is it didn't dissolve with the water inside, with the copper solution inside. It formed what we call precipitate. So this is the 5 ml of water. This is the 5 ml of water. We have scooped out our copper 2 sulfate, which is CuSO₄. Sample A. To dissolve it, I will there to dissolve it inside. Shake it. So that it can dissolve. And so you have dissolved it, right?
Yes, sir.
So this is the color after you dissolve it. This color, blue, Abby.
Yes.
Pale blue, it's not that blue. Pale blue. Then they will now ask you to drop sodium hydroxide. Sodium hydroxide is you have it in pellets. You need to dissolve it first of all. Use sodium hydroxide.
Okay.
The hydroxide solution is whitish in color, whitish, right? This one is pale blue. So now you are asked to drop sodium hydroxide inside the solution of the CuSO₄. In drop, we're going to do it in drops. So let's say that is in drops. So I've dropped like 3 drops. So what do you see here? So you are seeing something was shown. I don't know if you can zoom it, right? So now this is what we call gelatinous precipitates. Like the reason why you can see this stuff is it didn't dissolve with the water inside, with the copper solution inside. It formed what we call precipitates. Precipitates can be formed when you add 2 liquids together and it brings out a solid substance. That is what we call precipitates. But this one is not really a precipitate. Precipitate is supposed to be in solid, but this one is in gel form. Do you know gel? Gel.
Yes,
you know gel?
sir.
Yes.
Yes,
Gel. You guys use gel for their head. So it is in gel form. Can you see it now? It's in gel form. So what was formed? A gelatinous precipitate was formed. So after NOH was added in drops, okay, a gelatinous, gelatinous precipitate was formed. You are going to be given a table. You are going to have a table. Test is what you did. Then what can we say about it? Inference. Inference is what can you say about the observation? Insoluble. You know, the solution was insoluble. So copper 2 plus was suspected. So here copper 2 plus is suspected. Copper 2 plus is suspected. Why? Because it is only copper 2 plus that if you add NaOH with a solution, it's only copper 2 plus that is going to produce a gelatinous precipitate. We're also going to add it in SS. So in SS, that is test. That is test. The second one, add. Don't forget that this one, the first one, test 1. What did we do? Let's add it in SS. So what's going to happen? It didn't dissolve. It still remained the way it is. It still remains the way it is. It's continued being insoluble. Insoluble means something cannot dissolve, right? Soluble means something can dissolve, so it is still insoluble. According to what you have in your notes, you're going to write observation in the colon side. So what? Present or confirmed? Yes, confirmed. CuSO₂ plus is confirmed. So that's for that. So this is K-4. This is potassium permanganate. It's a strong oxidizing agent. I told you guys last class. Oxidizing agent causes the oxidation of another compound that is reacting with, while they themselves are what? Reduced. And reduction means to gain electron, right? So this is oxidizing agent, which is potassium permanganate 7, and it's always purple. Color purple, that's its color. So we have to add 5 centimeter cube of this guy in a test tube. So let's add it. We add it in this test tube. You know, the color is what? Purple, right? The color is purple. The color is purple violet. Thereabouts.
Yes, correct.
Purple violet. Now we are asked to add hydrogen peroxide. The symbol is H2O2. This is what we call hydrogen peroxide. Hydrogen peroxide. We're going to add it to this our KMNO4. You know, don't forget this is an oxidizing agent. If you add this one, this is a reducing agent. This is an oxidizing agent. If I add this one to this one is going to oxidize this one. This is peroxide. This peroxide, isn't it? So let us add it together. Look at it. This is H2O2. Apart from the neutralization aspect, it's brought out gas. You can see the gas that came up. That gas that came up is a significance that redox reaction has what occur. Do you understand? It has been reduced because the oxidizing agent is reduced, while this one being the reducing agent has been oxidized. Right? So that is what's happened. So this is it. Particularly. So I'm going to place it here first of all. That is funny. People are going to wear glove.
We have globe truly.
Yes, on the day of your practical. Gas is coming out. So that gas, glowing splinter, is going to. Did you notice that it made it catch very well? The point is that there's gas coming out from this hydrogen peroxide. If you carry a glowing splinter and you place it above, the glowing splinter doesn't burn, it only glows. It's not burning, it's only glowing. If you put it above, it's going to make it ignite, like the light, it's going to make the glowing to be more visible. Do you understand? So what's that one confirming? It's confirming oxygen. Oxygen, what is coming out is oxygen gas. You know? So introduce what do you observe? It's rekindles. It rekindles so that's going to tell you that the gas, what is inside is H2O2. They might just give you that, they give you an unknown. They won't tell you the name, they just give you. But you have to test it, what is inside. That's what we call qualitative analysis. So now they ask to write the chemical equation for the reaction that occur. That is H2O2. You're trying to break it down. It will give us water and the oxygen that makes the glowing splinter to ignite very well. Do you understand? So rekindling is the same thing as relight, in case you want to use another language. Relight, it makes it to light very well. Do you understand, Emmanuel? So this is the reaction. Is it balanced? Yes, it's balanced. This is 4. Hydrogen is 4 here. Hydrogen is 4 here. Oxygen is 2 times 2, 4. This one is 2 here, 2 here. So 4, 4. Yes, they will give us the sample. You want to test it if there's starch present in the food. And you guys know that there's starch always in rice, have you? Yeah. So we want to test it. So how do we test it? We're going to add the solution. You know. And we're going to add the solution to come right there. If I add the solution, can you see it turned black? It turned blue-black. By the time, if you leave it after a while, you will see that the black is going to be very prominent. You see, it's going to turn black. If you leave it after a while, the black is going to be prominent, very, very visible. So, because it turns black, not everything can tell. If you test beans, it's not going to turn black because beans is protein. Protein does not have starch in it. Observation: the sample turns black. Right now, inference is that starch is present. Starch is present. Blue. This is color blue, right? Let's see and see what happens. Did you notice any change?
Yes.
It's changing to what?
White.
White. The white is going to disappear and turn to blue. Back. Yes. It's going to turn to blue. That is just trying to signify chemical reaction. We have physical reaction and chemical reaction. So this one is reversible. Before it is blue, this one, after you heat it, it became white. Then when you came back, it became blue. Something like that anyway. But it's not your question. I'm just doing that one.